chapter 4, we're going to learn how to eventually prove that triangles are congruent, but we're going to talk about congruency, how to prove two triangles are congruent based on several methods. You're going to get a lot of acronyms this chapter, okay? Which means that the proofs are still in here, because I said the word prove two triangles are congruent, okay? They're not that bad. I promise you that the proofs get easier in this stuff, okay? I promise. So a lot of properties you already know about triangles are in this section. That's the good news, okay? Like, hopefully we know that it's a figure formed by three segments joining three non-collinear points. Definition of a triangle. The points where those segments meets are called the vertex. Each one would call a vertex, which plural is vertices. And the sides are segments. You can use that little symbol to name this, but this would be triangle ABC or BCA or ACB. You can put that in any order you want. The vertices would be point A, point B, and point C. And the segments are the sides. Segment AB, segment BC, and segment CA. And because these angles only have one, the vertex is only shared by one angle, you can call them with one letter. So angle A, angle B, and angle C. Okay, there's three ways to classify a triangle by its sides. Scalene, which means that no two sides are the same. Isosceles, which means at least two sides are the same. And equilateral, which means all three sides are the same. So can a triangle be isosceles and scalene? Can it be scalene and equilateral? Can it be isosceles and equilateral? Yes. Every equilateral triangle is also isosceles, right? Is every isosceles equilateral? No, okay. Then we're going to classify by angles, and there's four ways to classify by angles. Acute, obtuse, right, and equiangular. So acute is all angles are less than 90. Obtuse is one angle is greater than 90. Right is one angle is equal to 90. And equiangular are all angles are equal. So can a triangle be acute and obtuse? No. Can it be acute and right? No. Can it be acute and equiangular? How would that be possible? Good. If it was equiangular, then they all be 60. If they're always 60, then they're acute, right? Okay. Can it be right and isosceles? Yes. Okay. Can it be obtuse and isosceles? Yeah. Sure, right? One has to be bigger than 90, but we don't know anything about the other two. They could be the same. Does that make sense? Okay. Can it be obtuse and right? No. Obtuse, if it's obtuse, there's only one angle that can be obtuse. Everything else has to be acute, right? Because if it's obtuse, it's greater than 90, leaving the others to be less than 90. Does that make sense? Yeah? Okay. So the triangle sum theorem is something that you've heard about for a long time, hopefully. Okay? But it says the sum of the measures of the interior angles of a triangle is 180 degrees. So angle A plus angle B plus angle C is 180, and that's called the triangle sum theorem. So if you wanted to use this in a proof, you can even put a little triangle in the place of the word triangle, shorten it as much as you want. Okay? That's the triangle sum theorem. The exterior angle theorem says the measure of an exterior angle of a triangle equals the sum of the measures of the two remote, which is the same thing as non-adjacent, interior angles. So in this diagram, angle 1 would equal the sum of the two angles that are inside that triangle but not next to 1, which would be A and B. Okay, we're going to make a proof out of this. Fun stuff, right? So in order to prove, we want to prove that angle 1 equals the sum of the measures angle A and angle B. And we don't have to be given anything but a diagram. Okay? So what could you tell me about these angles? They add up to 180 degrees, so I could say that the angle 1 plus angle 2 plus angle A. Angle A plus angle B plus, we're going to call this angle 2 because that technically C is now shared by both angles. Angle 2 equals 180 degrees, and what would that be called? Triangle sum theorem. What else can we figure out from that picture? Good. Angle 1 and angle 2 are supplementary. And what's that called? Linear pair postulate. So if they're supplementary, then what's that mean? Then they add up to 180. And that's definition of supplementary. Now what?
Substitute something?
They both equal 180, right?
Yes.
So what's true? So A plus B plus 2 equals 1 plus 2. Yes? That's substitution. Now what? I can take away the 2, right? So I can subtract, there's a 2 on both sides. I could say angle 2 equals angle 2. What would that step have been? Reflection. So technically I should have done that first. But now I can say angle A plus angle B equals angle 1, and that was subtraction. So do you want to do that every time, or do you want to use the theorem that they just gave you?
Theorem.
Yeah, probably faster use the theorem. Should you forget that theorem, though, okay, this is how they came about it. All right, so you could now go from step 1, not even step 1. You could go from your triangle drawn to your answer, and your reason would be exterior angle theorem, okay? Okay, a corollary, by definition, is a statement that can be proven easily from a theorem. Okay, so I'm not going to really quiz you on the vocab of the word corollary, but you're going to see corollary, so don't freak out. So now we've got postulates, which are based on like definitions. You've got theorems, which somebody sat down and proved. And then you've got a corollary, which is something that's easily determined if you already know the theorem. The corollary to the triangle sum theorem says the acute angles of a right triangle are complementary. So if you know that all the angles have to add up to 180, and if you know one of those angles is a right angle, then the other two have to add up to what? 90 degrees, and two angles that add up to 90 degrees are complementary. So that's what this did. This just put two things together. And it's called the corollary to the triangle sum theorem. Laurel. Yep. So now you can use properties, definitions, theorems, postulates, corollaries. All right, so just to state whether the triangle with the two angles having the given measurements is it acute, right, or obtuse? All right, so look at A, 55 and 43. If I add those together, I get what? If I add 55 and 43? 93. Subtract that from 180 and I get what? 98. Oh, that's 90. Yeah. That's 98. 180 minus 98 is 62, which tells you that this triangle is acute. Okay, 47 and 43. 90. Subtract that from 180. 90, which means this triangle is Okay, next one, 80 plus 75. 155, subtract that from 180. 25, which tells you? A cube. Okay, 33 and 33, 66. 180 minus 66. 114, which tells you? Obtuse. And 24 and 66. 90, which tells you? 180 minus 90 would be 90, which is right. Mm-hmm. Oh, yeah. 82. Still a cube. Okay, now you're getting given a diagram, okay, and it says find the measure of angle A. So you want to look for congruency marks. In the case of A, what kind of angles do we have here? So they are alternate interior, but they're not parallel. Right? So unless it was, if it showed that they were parallel, then you could use that. Okay? What things do you have there that you don't need to know anything about the lines being parallel or anything like that? Reagan?
The triangle. Oh, wait.
You're going to use that. The triangle adds up to 180 degrees. You also have vertical angles. Everybody sees that, right? So remember I said vertical angles never go away. They don't. Okay? So for A, these are vertical angles, and vertical angles are always congruent. So if I did at 80 plus 50, I'd get what? 130. Subtract that from 180. 50 degrees, which means this is 50 degrees, and the other angle would be 80 degrees. Okay, the rest of them, so for B, you've got a congruency mark. If this is congruent to this, and this is 40, that means this last angle would be 60 degrees. See, again, you've got one congruency mark. If this is 30, this is 30, this is 110, then this is 110. So if I figured out that if I added these together, 140 from 80 is 40, which would carry over here, and then you'd find your remaining 110. Okay, find the measure of angle A. Now what kind of angle is that? What is 120 called? It's an exterior angle. What's true about the exterior angle? The sum of the non-adjacent or remote interior angles, right? So 120 equals the sum of what two angles? Angle A and 80 degrees, which gives you that 120 minus the 80 gives you angle A. Question so far? Okay, E says in triangle EFG, angle G is 100. So this is 100. And angle FEH, this one out here, is 3 times the measure of angle F. Find the measure of angle F. So if I were to put X in the place of the measure of angle F, let's say, then how could I write FEH's measure? 3 times X, right? And 3 times X equals what? 2 angles. F and G, which would be X and 100. So then subtract the X. 2X would equal 100. Divide by 2. And X is 50. These are easy to check. I could quickly plug that back in, right? If this is 50 and I add up 150, I get what? What's 100 plus 50? 150. Subtract that from the 180. What's the angle FEH gonna, or FEG gonna be? 30 degrees. Okay. Now these are a linear pair, which means the angle on the outside, that FEH is what? 150 degrees. Is 50 plus 100 equal to 150? Yes, right? Is 3 times 50 150? Yes. So it all should work, okay? Questions overall. It's a super easy section. We're just kind of going over some stuff about triangles before we get into proving the triangles are congruent. Hopefully this wasn't too bad.